Assalamu alaikum everyone. I hope you all are doing well. So last time we had seen the theory of 7.2. Let's recall one last thing that I want to remind related to theory, and then we will move to exercise formally. So we have seen that every square is a particular form of rectangle, and every rectangle is a parallelogram, and every parallelogram is trapezium. This is one thing, that if you start from a square, then every square is rectangle, and then every rectangle parallelogram, and then every parallelogram is going to be trapezium. So in the same way, we can also see that every square is also a rhombus, and every rhombus is a parallelogram, and then every parallelogram is again trapezium. So if you start from a square, then you can say that every square is a rectangle, and then every rectangle is a parallelogram, and then every parallelogram is a trapezium. On the same lines, if you say that your square is a rhombus, and then rhombus is a parallelogram, and this parallelogram is a trapezium. But other way around is not true. Like, you can't say that every trapezium is a parallelogram, and every parallelogram is a rectangle, and every rectangle is a square. So you can't go other way around, but you can go like square is rectangle, and rectangle is a parallelogram, and every parallelogram is a trapezium. Or every square is a rhombus, and every rhombus is a parallelogram, and then every parallelogram is a trapezium. So basically, this is one thing that is coming different in both of these sequences. So what is relation between these two? Like, so I would say that can we say that every rectangle is a rhombus, or every rhombus is a rectangle? So the answer is no. But we can say one more thing. And what is that one more thing? That one more thing is that in fact, square is only rectangle that is rhombus. Or you can say that square is only rhombus that is rectangle. So square is common between these two. Like, every square is rectangle, and the square is the only rectangle that is rhombus, and square is also the only rhombus that is rectangle. So square is basically intersecting between these two. Like, square is the kind of rectangle, as well as can be treated as an example of rectangle as well as rhombus. Let's move to exercise now. So the first question of the exercise is, find the coordinates of the midpoint of the line segment joining the following points. So you have to just apply the midpoint formula. So as we have done the theory, so I'll only do part D. And part D, we are given a comma minus b, and then minus b comma a. So let's call this x1 y1, and then x2 y2, and then using formula we can solve this. This is the formula: x1 plus x2 upon 2, and then y1 plus y2 upon 2. This is the midpoint, basically midpoint between, let's say, these points. This point is a, and this point is b. So this is going to be, what is x1? A. What is x2? Minus b divided by 2. What is y1? Minus b. what is y2? A divided by 2. So basically this is going to be a minus b over 2 comma a minus b over 2. So you can do that. And question 2, it says that if 3 comma 5, let's do question next question. And this question, it says that m, question 2 of 7.2, it says that m 3 comma 5 is the midpoint of a and b. What is the a? So a is going to be minus 3 comma 7, and what is b? The b is p comma q. Find the value of p and q. So this is the midpoint of these 2 points. We have discussed such thing in theory as well. So let's label these x1 y1, x2 y2. So we know that midpoint is equal to x1 plus x2 upon 2, and then y1 plus y2 upon 2. What is our midpoint in this case? It is 3 comma 5, and then what is x1? Minus 3, and what is x2? P divided by 2. What is y1? 7, and then what is y2? It's q divided by 2. So since the points are equal, so we must have this thing that this is equal to this, and this one is equal to this, or we can say that minus 3 plus p over 2 is equal to 3, and 7 plus q over 2 is equal to 5. Just solve these solve these equations for p and q, and then you will get the values of p and of q. Let's move to next question. The next question is question number 3, and it says that the midpoint of the line joining a and b are 5 comma 1. The midpoint of line joining a and b are the coordinate of the midpoint. Okay, so it says that you have 2 points a and b. What is a? A is my p square comma p, and what is my b? My b is q square comma q. And what is their midpoint? Their midpoint is 5 comma 1. So now it says that find the possible values of p and q. So since this is the midpoint of these two, so let's find midpoint of these two. So midpoint of these two is p square plus q square over 2, and p plus q divided by 2, and this midpoint must be equal to 5 comma 1. So you get two equation, p square plus q square divided by 2 equal to 5, and the way we did last time, like this is equal to 5 and this is equal to 1. So p plus q must be equal to divided by. So these are two simultaneous equations. Solve them simultaneously and get the values. You have learned in chapter 2 how to solve two simultaneous equations. So in question 4 it says that 3 points have coordinates. What are those 3 points? The one point is minus 1 comma 6, and the other point is 3 comma 2, and what is the third point? That is 5 comma minus 4. It says that given that D and E are the midpoints of AB and AC, so this is my D, which is midpoint of these two, and it says that E is midpoint of AC. So like I should have written this C somewhere else. So write another way. Okay. So like let's write C over here. So this is my C, and C was what? C was minus 5 comma minus 4. Okay, so like now E is midpoint of this A and C, so you can just use the midpoint formula and calculate this E, and use the midpoint formula for A and B, and then calculate this D. So like it's like C A B. I'm writing this way, but these points might not look like this. So E is the midpoint of these two, and D is the midpoint of these two. So you can calculate D and E. And then it says that respectively. Calculate the midpoint of DE. Then it says that once you have calculated this T and E, then it says that calculate midpoint of these two, let's call that M, and then said the length of D. Also, since you have D and E both points, so you can calculate the length of D and E as well by using distance between 2 points formula. This was all. Okay, I hope you got that idea. Okay, so let's move question 5. Question 5 says that the three vertices of a parallelogram are A, B, C, D are A is 9, 3, B is minus 2, 1, and C is 8, 6. So write down the coordinates of midpoint of AC. So you can calculate the midpoint of AC, like A is 9, 3 and C is 8, 6. So you calculate just midpoint between these two, which is M. And then it says that write down the coordinates of midpoint of AC and hence or otherwise find the coordinates of fourth vertex. So since it was a parallelogram, and what we know about parallelogram, what we know about parallelogram, let's do this way. So for parallelogram, we know that for parallelogram, diagonals bisect means diagonals cut each other at midpoint. So you had a point A, a point B, a point C, and a point D. So this was basically our parallelogram that we were given. So what we have calculated right now, we have calculated this midpoint, so it was midpoint of A and C. So it says now calculate the fourth vertex. So since this is midpoint of diagonal AC, so it must also be diagonal of BD. Why? Because it's a parallelogram, and we know that parallelograms diagonals bisect each other. So now what will you do? So you have this midpoint, you have this point B, so then you can repeat exercise 2, question 2 of 7.2, where 2 points, let's call this X and Y, and then you have B, which is minus 2, 1, and you have calculated this midpoint, this one. So you just need to use that x minus 2 over 2 and y plus 1 over 2. This is the midpoint of D and B. It must be equal to whatever the midpoint this is. These coordinates are already known to you. So from there you can calculate the values of x and y. You can write P, Q maybe. So here it will be P and here it will be Q. So in that way you can calculate P and Q, and that will be your fourth vertex D. Prove that ABCD is a rhombus. So you just need to show that AB is BC is CD is DA. So in parallelogram is rhombus only when all four sides are equal. So now in question 6 is very easy. A, B, C, D are the vertices of parallelogram. Calculate the value of P and of R. So one thing that is very easy to conclude from the question is that diagonals bisect. So in question number 6, A is 2, 0, B is P, minus 2, C is minus 1, 1, and D is 3, R. So A, B, C, and D. This is your parallelogram. Uh, So what will you do? You will calculate the midpoint of this AC and midpoint of AD, and you will equate these, like you will keep equal the midpoint of CD and AC and BD, and from there you will calculate P and R. So I hope you will do 7 by yourself. If you have any issue in question 7, you can write down in comments, and then I'll make a separate small tutorial on that. Thank